Let's solve a couple of problems based on whatever properties we have done. Okay, let's start from the first one. See, it says 3 sine inverse of x is equal to sine inverse of 3x minus 4x cube. X belongs to minus half to plus half. The range is given to you. Okay, let's start from the first one because it's quite easy and simple, I would say. For A, can't you figure out the logic here? Because you're looking at sine 3 theta formula, right? Let's start solving with the help of sine 3 theta. So you have, let's say sine inverse of x is equal to y. Alright. Next, what we'll do? X is equal to sine y. Next, we'll do sine 3y. Sine 3y is what? 3 sine y minus 4 sine cube y. Okay, now RHS is going to become 3x minus 4x cube. LHS is going to be sine 3y. So 3y is equal to sine inverse of 3x minus 4x cube. Guys, what is y? Sine inverse of x. So 3 sine inverse of x is equal to sine inverse of 3x minus 4x cube. See? Very, very simple logic, isn't it? Now, I want you guys to pause the video and solve the second one. 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x. I'm sure you guys use the same logic as the previous one, correct? So what are you going to have here? You're going to have take cos inverse of x is equal to y. So you have x is equal to cos y. Then take cos 3y, which is going to be 4 cos cube y minus 3 cos y. What is cos y? Cos y is basically x. So you have cos 3y is equal to 4x cube minus 3x. Right? So 3y is equal to cos inverse of 4x cube minus 3x. So y, what is y? Y is basically cos inverse. So 3 cos inverse of x, cos inverse of 4x cube minus 3x. Make sense? Now let's do the third problem. See, you have 2 tan inverse of half plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 17. First, you apply the formula to tan inverse of x. Tan inverse of 2x by 1 plus x square. Sorry, 1 minus x square. Again, I'll tell 2 tan inverse of x is tan inverse of 2x by 1 minus x square plus this one. Then you have to apply tan inverse of x plus tan inverse of y. Okay, let's do the math here. Let's see how to solve this one. 2 tan inverse of half, right? So we'll write 2 tan inverse of half is equal to tan inverse of 2 into half by 1 minus 1 by 4, half square. Cancel, cancel. Tan inverse of 1 by, see 1 minus 1 by 4 is 3 by 4. So this becomes tan inverse of 4 by 3. Now what is the actual question here? So instead of 2 tan inverse of half, you can write tan inverse of 4 by 3. So tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now use tan inverse of x plus tan inverse of y. Tan inverse of x plus y by 1 minus xy. Correct? So apply the formula. You will get tan inverse of 4 by 3 plus 1 by 7. 1 minus 4 by 3 into 1 by 7. Correct? So if you do this one, this implies tan inverse of, take the LCM, you'll get 28 plus 3 divided by 21. Again, 21 minus 4 divided by 21. 21 cancels. tan inverse of 28 plus 3 is 31. 21 minus 4 is 17. You got the answer. Or in other words, we can write, therefore, finally, therefore, 2 tan inverse half plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. Clear? This is going to be the proof for this one. Let's do similar type of problems, like few more problems of similar type. Let's do simplification type of problems. Alright, look at the first one. Tan inverse of root of 1 plus x square minus 1 divided by x, x is not equal to 0. See, whenever they say write in the simplified form, you basically have to substitute a value for x. Okay, the first one I'll show how to go about it. See, you have tan inverse of 1 plus x square, root of 1 plus x square minus 1, isn't it? Now, there is a thumb rule we can call it, or like bottom line what you have to do is, if you have 1 plus x square, generally you substitute x as either tan theta or cot theta. Okay, the reason is, remember the trigonometric identity 1 plus tan square theta, secant square theta. 1 plus cot square theta was secant square theta. Correct? So you have to understand why we are substituting that particular value, right? So whenever you have 1 plus x square, so keep this in mind. This is more like a bottom line thumb rule. Thumb rule is this. If you have 1 plus x square, substitute either tan or cot. Okay? If you have x square minus 1, like in what you have in the second one, then substitute either cosecant or secant. Alright? If you have 1 minus x square, then you substitute sine or cos. Fair enough? Let's do the first one now. So for the first one, what you will do, take x value as tan theta. You can substitute cot also, makes no difference. So you'll get tan inverse of root of 1 plus tan square theta minus 1 divided by tan theta. Correct? See, in the inside the bracket and inside the root, this part is going to become secant theta, right? So you will get this as tan inverse of secant theta minus 1 divided by tan theta. Secant theta is 1 by cos theta. Tan theta is sin theta by cos theta. Isn't it? So if you do that, you guys are going to get tan inverse of 1 by cos theta minus 1 by sin theta over cos theta. Take LCM and simplify, guys. Tan inverse of 1 minus cos theta divided by sin theta. Because what's going to happen? The cos theta gets cancelled, isn't it? Now comes the very important part, which is the simplification. Because 1 minus cos theta, you have to write in terms of the half angle. That is tan inverse of 1 minus cos theta. If you have 1 minus cos theta, this is going to become 2 sine square theta by 2. 2 sine square theta by 2 by 2 sine theta by 2 into cos theta by 2. 2 cancel, 1 sine cancels. Which finally you will have tan inverse of tan theta by 2. Therefore, what is the value of theta now? Or the function tan inverse of tan theta by 2. The answer is going to become theta by 2. So theta by 2 is the final answer. The reason is you have 1 minus cos theta, convert that into half angle. So that you have to simplify every question you have to simplify. Alright, the final answer for the first question is going to be just theta by 2. But what is theta? Tan inverse of x. So finally, you can write this as half tan inverse x. Half tan inverse of x. This is going to be the answer for the first question. Alright, let's do the next one now. You have tan inverse of 1 by root of x square minus 1. Correct? Now let's substitute. See here, take secant because there is a relation between secant and tan. Take it as secant. Okay, let's try and solve this one. See the next one. You have b. So what did I tell? Take x value as secant theta. So you will have tan inverse of 1 by root of secant square theta minus 1. Tan inverse of 1 by secant square theta minus 1 is tan square theta. Root of that is going to become tan theta. You cannot cancel the tan and tan inverse right now. But what you can do is tan inverse of cot theta. Correct? Now, cot theta write in terms of tan. That means you will have tan inverse of tan of pi by 2 minus theta. So, final answer is pi by 2 minus theta. Guys, what is theta? Secant inverse of x, right? Look at this one. Secant inverse of x is going to become theta. Therefore, final answer is pi by 2 minus secant inverse of x. This is going to be the answer for the second one. Let's do the third problem now. See, for the third one, here no substitution. Just simplify 1 minus cos x and 1 plus cos x in terms of half angle. Tan inverse of root of 1 minus cos x to sine square x by 2 by 2 cos square x by 2. 2 and 2 cancels. Tan inverse of root of tan square x by 2. Tan inverse of tan x by 2. So final answer is going to become just x by 2. It's a very simple problem. Understood? The problem is the answer is going to be just x by 2. There is no tan inverse, there is no sine whatever.